Other one is April 27th. All right, let's do this. We're still counting subarrays. We're counting subarrays every single day for the past, I don't know, 2 weeks. Every day is counting subarrays. This is a new subarray. Count subarrays with score less than k. The score of an array is defined as the product of its sum and its length. For example, the score of this is the sum times its length. Given a positive integer array and an integer k, return the number of non-empty subarray of num so the score is strictly less than k. Strictly less than k. Okay. So the score is the score is the sum. So the sum we can do prefix sum, right? So p sum will be 2, 3, 7, 10, and 15. And we want the subarray multiplied by its length. Well, the sum is increasing. Well, yes, the sum always increases, right? Sum always increases. And the size also increases. So it's likely that if we go 2 pointers and I put 1 pointer of a low here and a high as our wall, right? So basically you're saying they say all the subarrays ending or all the subarrays starting. Right, so all the subarrays starting from here. So 2 and 2, it works. So here is going to be 3, that works. Going here, it doesn't work, right? So starting from 2, all the subarrays ending at here. That's it. It cannot move further. Right, because I try to go here, but it didn't work. And yeah, so you start from something, and then you start from here, and then you can say 1, that works. 4 doesn't work. Right, if 4 doesn't work, none of the rest will work. So starting from here, I have 2. Right, and then we move on. Low coming here. Now low coming here. High is pointing to. Well, if it doesn't work, I should move back. So high is still pointing here. So high should move back to the previous one, because if this doesn't work, I move forward. You see that's the same issue, right? Because I can go from a subarray. They start from here, and every single one works. And I move to the next one, I have to move it back, so I have to redo this whole thing. Right? So that's, again, that's the problem. So what we want is once I know from one of them, right, starting from 1, I get all possibilities, and I move on to the next one. So when you move on to the next one, let's do it one more time. So I have A0, A1, A2, A3, AN minus 1. So let's say from A0, I can go to A3. Okay, so this is the maximum you can do, and also you have all these. Now, if I move on to the A1, right? I move on to the A1. If I move on to the A1, the question is, do all of these still work? If all of these still work, then I don't have to move the high. So like the high is pointing here, right? high is pointing here, which is the first that doesn't work, and then I can compute the whole thing, and I move forward. Now the thing is, do all these work, like A1 to A2, A1 to A3? Now, because everybody is larger than 0, larger than 1, so if, basically we're saying A0 plus A1 plus A2 multiplied by 3 is working. A0 plus A1 plus A2 plus A3 multiplied by 4 is working. So I want to know if A1 plus A2 multiplied by 2, A1 plus A2 plus A3 multiplied by 3, are they working? Right, so basically this is smaller than K. This is also smaller than K, right? So this is what we have. And I also have the sum, right? I have the sum. So technically, I know this. This I know, right? This I know. Because I remove A0, then that's that. My intuition is it will work, right? Because if this works, right? If this works, which means 3A0 plus 3 times A1 plus A2 is smaller than K, which means 3A0 plus A1 plus A2 plus 2 times A1 A2 is smaller than K. Something plus a positive value is smaller than K, so this must work, right? And similar for this. Similar for this. We can use the same strategy. This, if you expand, is 4A0 plus, A1, A2, A3 plus 3 times this thing is smaller than K. So if this one works, then this must be smaller than K, which means as we go, we hit something that's impossible, we get this. We move forward, immediately we can include everybody, right? We can include everybody. And I try it again, right? I try this. Okay, now I want to test this in this, right? So I start from here, right? 2 works. That's 3 times 2 is 6, right? It works. That's 7 times 3, it doesn't work. So high is here. So now we say high minus low, 0, 1, 2, high minus low, so we are plus 2, right? And then we move low here. So I move low here, immediately I can add. I can just keep moving this. I keep moving this, right? Because this one is counted, right? So now the total sum is still 3 because this one I didn't add, right? So now total sum is 1. So 1 is working, and I think high shall move back. High shall move back, right? High move back. So then high will move forward again, right? High will move forward again. Because every time I want high move forward, and now I'll add, now this at 1 plus 4 is 5. 5 times 2, it doesn't work, right? It doesn't work. So now I plus 1, and this will retreat. Because it doesn't work, it will retreat. And then low moving forward, okay? And a high, again, move forward. So we basically, now we just add 4. 4 works. And a high come here, doesn't work. So high will move back, so we'll add 4. And then the high is here, low now comes here. So high comes here, so 3 works. And then doesn't work. So high come back, so low come here. So yeah, so that's kind of how. Let's say this 1, 1, 1. Okay, 1, 1, 1. Low is here, right? It works. 2 times 2, it works. 3 times 3 doesn't work. So high comes here. High minus low plus 1 is 2, so plus 2. Now low will move forward. Right, because high come here, so high now move forward. It works. And then they come out. Right, high goes out. High cannot go out, so it fails. So high come back up, and then this again +2. And then low move forward again, and then high go out. It doesn't work, right? So high coming back and +1, so low going forward. So it seems like the way I am thinking about this, low should be the one moving forward. High can, jump back and forth, jump back and forth. All right, let's give this a shot. All right, so 2 pointers. Okay, we have long result. Okay. Oh, we also need a sum. Do I need a... Yeah. I'm not sure. 10 to the 5th times 10 to the 5th. I think we need a long as well. So, long this and then the S. Okay. Each time I will add, so it's a S plus equal to nums high. Actually, yeah, and then we say if S times high minus low plus 1 this is when we need to handle it. So how we handle it is we will reduce on high, so high will minus S equal to nums high, right? This is the we need to get S back, and the rest plus equal to long high minus low plus 1, right? And then we need to move a low forward. Oh, that's not right. That's not right. I think we need to do it differently. Like if high is smaller than n, right? And if high is larger or equal to n, or right, and then we move high back. Maybe we shouldn't do this. Let me think. What will be the best way to detect if it's a bad thing? So we can say if it's good, now just increment. That's it. If it's not good, right? So basically we can do this. If high is this, and s plus nums, right? S plus nums high multiplied by high minus low times 1 is smaller than k, which means, yeah, we are happy with what we have. Then I just increment. Else means we are not happy, right? If we're not happy, we haven't changed s yet, so nothing needs to move. If we're not happy, then we will, first of all, yes. Hold on. Are you incrementing on high? So I'm not incrementing on high. So which is like we want to try. So high is pointing already to the next one, right? So high always pointing to the one that you haven't handled yet. But I'm just trying, right? I'm trying to see if I include this, will it work? Like if it does, then I do this and I'll increment on high again, right? Otherwise, that means high is bad, right? High is bad. Now, if high is bad, we can, of course, firstly, we update the result, right? And then we need to move low forward. Now to move low forward, we need to, because s hasn't incremented yet, so we can s just minus equal to nums low, and after that we can plus plus, right? And if every time we do this, it has to go long, unfortunately, right? Long and long, right? And then when we do that, low will move forward, and that's it. And then next one, we'll try it again, right? We'll try it again, and eventually, because high will get to n, right? High will hit n. If high hit n, we basically just increment on the result, right? I keep removing low, and the low will move forward, and then low become unsustainable. Eventually, low gets out, and I'll return the result. Okay, let's just take a crack. Okay, something does not feel right. Right? Alright, let's see. Does it work? Looks solid. Let me just submit it. Let's try to see if it works. Well, looks pretty well. So 6 milliseconds with a 30%. I am confused. Why it's only 30%? I feel this is pretty fast, or no? Maybe there is something that we can do better. For example, when the high gets out, right? When the high gets out, then we basically, if high is equal to n, we always come here. Yeah, because if high we keep extending to n, then we don't have to do the loop anymore, right? Because I always add this high minus low is just exactly the result, and we just adding all those up into 1. So I think what we can do, hold on, what we can do is update when high when high is n, we can exit the loop because the remaining count of subarray can be computed mathematically, which means I can do this and high is actually we just need to do high smaller than n, right? Well, high is smaller than n because high is already smaller than n, so I don't even need to do this. I can just go ahead and check, right? I go ahead, I do this check, this will go, and then it will get out. And if it's bad, then we'll do whatever this. So every time, okay, now when we're done, right, when we're done, we'll say rest plus, of course, we go long, it's gonna be 1 plus high minus low, right? High minus low times high minus low divided by 2. So that's how I think it will work, but we have to get some example out of it. Okay, it looks good. Let's try it. Yep, now we get a 4 milliseconds and 48%. Okay, 4 milliseconds, 48%. Can we do even faster? Not quite sure. So essentially, yeah, I don't know if we can even do faster than this. Alright, I'll stop right here and then check the editorial. Sliding window. Total plus. Yeah, we just add some and then we shrink until we cannot. We add everything and we add, yeah, this is very standard way. Yeah, it's pretty standard. I don't know why I didn't do it this way. Okay, let's do the standard solution. Very curious. So this is the standard solution. This is the standard solution from the official, from the editorial. So the standard solution is for int high 0 high smaller than n high plus plus. Okay, and each time I will update the s. Okay, so it's s plus equal to nums long nums high, right? And now we say while low is smaller equal to high and s times high minus low plus 1 is smaller, is larger equal to k, right? When that happens, we shall say s minus equal to long nums low plus plus. Okay. And once we get out, we get the array that satisfies, right? Which is ending at here. What is the satisfy? So rest plus equal to long high minus low plus 1, right? And then high moving forward as usual, and then we'll return rest. All right, something like that. Is it working? That looks good. Yeah, I think this is exactly the same. I wonder how fast this can be. It's the same. Yeah, it's the same. All right, that will be it. Scary upon first look, but overall it's not that bad, right? It's not that bad. All right, that'll be it. I don't want to do another one.